So this is a section, and basically what we usually call this section is the geometric mean, a section on the geometric mean of right triangles. There are three similar triangles here. We're talking about similar triangles on the test. Well, there's three similar triangles in this one drawing. And this can be hard for me and some people. Well, so if it's hard for you, I get it, okay? Here's one. I'm gonna turn all my triangles to be oriented like the one I just outlined in green, and I'm gonna kind of color code them. So if I put the right angle down here, and then I'm gonna put X here and 8 here, I'm going to show you there's three triangles here that actually match up this way. There's another one. The big triangle is another one. So I could draw the big one too. And for the big one, I know the right angle is going to go here. And this side, the short side, is right here on this big triangle. I'll mark it with a mark. It doesn't have a number on it. And let's see, the hypotenuse of that big triangle would be 8 plus 2, right? Because here's the right angle on the big triangle. And so across from it's the hypotenuse, and it's that whole side. So that is 8 plus 2 is 10. And there's no other sides labeled on the right triangle, correct? If I were to mark this side with 2 marks, that's matching up here. So sometimes it helps to redraw these and make them face the same way so you can see how they relate to each other, because usually you have to do that to solve a problem. There's a third triangle here that's a right triangle. So I'm going to draw it like this, and its side 2 is the short side of that one, is kind of how I usually word it. And the longer side here is X. These three triangles are similar to each other. So if I want to find, what they do is this line down the middle, they call that the geometric mean of the right triangle. And if you notice, it's in two triangles here, right? I can solve for that. If I kind of unravel this thing and separate the three triangles up, I can see how I can solve for this. If I want to solve for X, couldn't I say now, look at the green one and the red one. X goes to 2, doesn't it? The way that 8 goes to X. Y'all see that, how I'm matching it up? This side here matches up with this side. And I'll use yellow, the way that this side here matches up with this side. So you kind of have to turn these, and the book drawing is better than what I did, on the iPad for sure. If you look at that, you can really see there's a short side, there's a short leg, there's a longer leg, and the hypotenuse is always easy to find because it's across from the right angle. So you kind of have to unfold these. Somewhere in this mess over here, I have a big copy of these, and I'll try to find that today. I just didn't have time this morning, where it actually, you can pull them off and see how it works. So I'll look for that. I had it over here for a while, but it got rearranged when we were messing with the TV up here. So anyway, I can solve for this by cross multiplying. 8 times 2 is 16, and X times X is X squared. So if I want to solve for X, what's the opposite of squaring? Square rooting, right? The opposite of squaring is square rooting. So X would be the square root of 16 is 4. So I would know that X is 4 here. I can solve these triangles this way, because I didn't want to include this chapter on the test. I wanted to chunk it up a little bit smaller. So we have X there. They bring down this right angle here. This little piece here is 4, and this whole side is 9. So you got three triangles, and what you're looking for is, how can I relate two of them together to get a proportion? So you pretty much always unfold these the same way. Let's start with this one right here. Here's a right triangle, so I'm going to color code. And I don't know any of the sides of that right triangle that's red, do I? If you look at the book, there's nothing labeled on it.
Actually, you can. You can figure it out because the whole base equals 9, and if one of them is...
Oh, you're right. Yeah, if that's 4, this is 5. You're right. Thanks for pointing that out. Good. Yeah, you can figure that out. I don't have another side there, so it's going to be kind of hard for me to use that in a proportion because you've got to have 2 sides to make a proportion, and there's only that one piece there that we know. So they didn't give us very much information about that one. Now let me look at the other small triangle, which is this other one over here that you put it together to make the big triangle. So I'm going to go ahead and draw the same figure. And let's see, on that figure, that 4 ends up kind of tilting. If you took that 4, that side that I've labeled, and you just kind of tilted it this way, like that, you'd see how to set it down like the red one. So when you tilt, if you can imagine pivoting that down around that right angle, the 4 goes here, and the hypotenuse is X, isn't it? We still don't know what that piece in the middle is, so it's still missing. It's on, that's this missing piece here, and over on this other triangle, it was the missing side there. Now let's look at the big triangle, the overall one that this, I'm kind of highlighting the whole thing there. If you look at it, you know the hypotenuse is 9, and let's see, this side right here would be the X, okay? If you can imagine that thing, it's kind of like sitting like this, and you're going to kind of flip it up like this and straighten it a little bit. This is your, normally, a lot of times, if you get confused, like for instance, look at 15. It was easier to tell, wasn't it, what was going on? This one is set up that same way. It's just that since they drew the sides where they looked more equal, it's a little more confusing. So you can actually go over to triangle 15 and kind of see how to set it up, and that'll help you with 16 and like 18. If you just look at another drawing of them, at least they oriented those in the same way, so you can kind of see there's more of a difference on the problem number 15 there. To me, this is kind of hard to get it turned because I'm not abstract. It's see, let me look.
If you move it to the right, then it would stay at the bottom where it is.
Well, if you, the big one?
Yes.
If you can imagine taking it, it's like this, and you're going to flip it up.
Oh, you're flipping it?
You flip that big one up to set it where its right angle is down like this.
Turning it.
We turned the green one. Okay, like I said, I'll find that big model one. I've got one that's about this big, and it's got Velcro on it, so you could actually see how to do it, and it helps a little bit. It's probably in here. I probably could find it here in a minute. So now that I have this, here's another reason I know I set it up right. Look, the red one didn't have enough information, did it? I can't solve anything here if I can't get a good proportion out of it. Do you see that on the green and the blue one now, the same sides are labeled? That's another kind of just a confirmation to me that I did it right, because those sides match up now. I can't solve this if I don't have 2 triangles where the sides match up. And so I do here. So that's another way you can kind of know that you've done something right, is if you get 2 of them that have the same sides labeled, it's a good hint that you've done something right. Okay, so if I want to set this one up, let me see, let me pick a purple color. I'm going to be looking at the green one and the blue one, and the only reason I chose those is because they have the same sides marked on their triangles. So if I go, I'm going to start on the left one. X matches up with 9 the way that 4 matches up with X. So far, what's happened in both of these problems when I cross multiply? Yeah, the X is squared. That X is the geometric mean there. X squared is 36. And if I square root both sides, X is equal to 6. Do you remember when we were looking at proportions? I think that this was in here. I may be getting it mixed up with the 6th grade class. When you have a proportion, now, a lot of it has to do with, I guess, the way we set it up. These outside pieces usually are called the extremes, and these two inside, because if you start and you were to think like X is on the outside, then 9 and 4 are kind of in the middle, and then the other X is on the outside. We usually call the two numbers, I'll mark them like with a squiggly on them or something. That's usually what we call the mean there in a proportion, but the geometric mean here ends up being usually it refers to this line right here. You don't really need to know that term so much, even though they use it as the title here. You just need to know how to turn and set up these similar triangles is basically the idea here. And if you get confused, if you kind of go to one that's where they've made the sides a bigger difference in the length of the two legs, it's easier to set it up because you can really see how it matches up a little bit better. Look, did you say 18 or 19 a while ago? Was it, Megan, didn't you have like...
18.
Let's look at 18. We'll go ahead and do another one of these. Okay, so this one, they've turned it a little differently, which makes it challenging to me because I have issues with these things. It's really, I have to really think hard to get these right. We've got 20 is this whole side here. They labeled this little piece X. So couldn't I say that this piece, let me highlight it in yellow, isn't this piece right here going to be 20 minus X? Right? Because the whole thing is 20, and that little, let me write it in black. Wouldn't this be 20 minus X right here? Because the whole thing's 20, and if you take out that little piece that's marked X, it would be the whole thing minus the little part. So that's how we could label that. And that's part of the thing. Even in your test tomorrow, there's going to be some problems where you have to do that. You have to look at the big piece minus the little piece to get another part. This side is 9 here. And then they show us that the two right angles, well, there's a right angle here. So our big triangle is actually set up like this one. It's setting up the way the problem is drawn in the book, and we've got 9 and 20. Okay, so I'll just draw the big one like that. Let me get the, let's start with this one right here, maybe the medium-sized one. If I draw that medium size, and oops, sorry, I forgot to turn that off. If I set that up like this, you can tell here at least there's a shorter side to the right, shorter leg and a longer leg. So that kind of makes it a little easier to set up. These are always a little bit easier. We don't know the short leg here, but we do know the long leg is 20 minus X. So I can label this 20 minus X. Do I know any other sides on this, the red triangle that I highlighted here, which is kind of the, I would say, medium-sized one? There's no, like, this side's not marked, and this side's not marked, is it? So, do you think I'm going to be using that triangle in my setup for my proportion, if there's only one side? Yeah, probably not, right? Because I need two sides. Okay, well, I'm going to have to speed this video up or it's going to time out on me. Okay, so let's look at this one. I'm going to set it up where the right angle is like this. Again, look in the book because the book's drawing is much better than mine. So that little triangle there, the short leg is X and the hypotenuse is 9. How do I know I probably did something right in setting this up?
Because the sides are...
Yeah, I'm getting the same sides labeled. Look here. Those two sides match up and they're labeled. And that side match up and they're labeled. So I can make a proportion. If I don't get a proportion out of this, there's no way to solve it, and they told me I'm supposed to solve it. So I can say this yellow 9 matches up with the yellow X the way that the 20 over here that I circled in blue matches up with the 9. Okay? So if I cross multiply, 9 times 9 is 81, and then 20 times X is 20X. So if I want to solve for X, I'm going to divide by 20 on both sides. So 81 over 20, that would reduce. Well, will it? No, because 81 is 3 times 3 times 3 times 3. And 20 is 2 times 2 times 5. They don't have any factors in common, so I'll just leave my fraction like that. 81 over